This lab introduction video is going to walk through a tutorial on how to use the virtual lab for ionic bonding. Okay, so the lab paper is on the left and I have the link simulation at the right. So we're going to use this PBS learning media simulation. So when I clicked on this link, it opened up this page and you just have to click here to launch it. And when you do that, you get this interactive tutorial to open up. Okay, so throughout this activity, it's going to discuss ionic bonding and investigate how the transfer of electrons between atoms creates ions and how the mutual attraction of those forms ionic bonds. And we're going to use that to learn about some trends in the periodic table and explore how the structure of a compound relates to its formula. There are several questions here to answer related to both what you've talked about in class and what you see in the tutorial here. Okay, so using what you read here and do here and what you know can answer these questions. Okay, so first of all, just a little introduction. So you're just going to use the arrows to go through and just complete the thing. So the box contains two negatively charged ions. Drag one of them closer to the other and see what happens. Okay, so you can see what's happening there. Okay. Now let's look at how ions with opposite charges behave. So if I move one of the ions closer, what happens? Okay, just make some observations there. The opposite ions attract each other, and when close enough, they stick together. So how can we use this to build ionic compounds? One, opposite charges attract and stick together. Like charges repel each other. In order to build an ionic compound that sticks together, you need opposite charges, both positive and negative ions. The positive ion is formed from an atom that has a tendency to lose electrons. Since metal ions can easily lose electrons, the positive ion will usually be a metal. Again, keeping in mind these questions over here you need to answer. Atoms on the left side of the periodic table tend to form positive ions. The negative ion is formed from an atom that has a tendency to gain electrons. Since nonmetals here form ions by gaining electrons, the negative ion will usually be a nonmetal. Atoms on the right side or the upper right corner of the periodic table tend to form negative ions. So here's where we're at. Metals form positive ions. Nonmetals form negative ions. So metals and nonmetals bond together by forming an ionic bond. How does this work? So let's choose sodium as our metal and chlorine as our nonmetal. Chlorine atoms have a strong attraction for electrons, and under certain circumstances, the chlorine atom would be able to take one electron from the sodium atom. An electron is ripped from the sodium atom, turning it into a positively charged sodium ion. The chlorine atom gains the electron and becomes a negatively charged ion called chloride. Okay, so the two atoms are now oppositely charged and are called ions. Okay, so you could see that electron was transferred from the sodium to the chlorine. Now we have a sodium ion and a chloride ion. Since they have opposite charges, they're attracted to each other and are held together due to that attraction between the opposite charges, which is known as an ionic bond. That's obviously a simplification of the process, but let's look at it again in a way that more closely resembles the way the atoms would interact in the real world. So chlorine is typically a gas with atoms found diatomically in pairs. And sodium is typically a solid metal. When it's heated, it vaporizes and separates the individual sodium atoms. So each chlorine atom in the chlorine molecule needs one sodium atom to interact with it. And the end result is that each sodium ion is bonded to a chloride ion. Remember that opposite charges attract, so watch what happens next. The positive ions will attract any negative ions around them, just as the negative ions will attract any positive ions nearby. Cool. Many ion pairs will spontaneously self-assemble into an ion crystal. So again, thinking about our questions over here. Isn't that cool? So how does that happen? Because the positive ion is attracting other negative ions, and the negative ions are attracting other positive ones. This continues in 3 dimensions until no more ion pairs are nearby. So we can look at this 3-dimensional sodium chloride crystal. Okay. In the 3D model, each ion is surrounded by oppositely charged ions, and there are no distinct molecules. Instead of this compound being called a molecule, it's called an ionic crystal. How do we write formulas for these compounds? So let's take a look at the crystal. Tap on each icon below to count the number of sodium ions and chloride ions. So if I'm counting sodium, I have 1, 2, 3, and I have similarly 1, 2, 3 chloride. There was 1 sodium ion for every chloride ion. Since the crystal contains a 1-to-1 ratio, we would write the formula as NaCl. There are no molecules in this ionic crystal. In ionic compounds, the formula just tells us the ratio of ions, not the total number. Okay, so we can do this for another crystal. This is calcium and fluoride. So if I'm going to count the calciums, right, I can count them. How many do you see? 1, 2, 3. If it's, let's say, 4. And then there's how many fluorides? 1, 2, 4, 8, right? So that would be CaF2. Okay. All right. So just a conclusion. All right, and we are done. So that's walking you through the entire tutorial. And you can see these questions on the left. Follow along with the tutorial that you can answer, and then you are done.